James Webb just grabbed a fresh frame of 3I/Atlas, and one detail is weird enough that people are already jumping to wild conclusions. Subscribe, because we're going to check the facts the boring way, and that's how you catch the truth. Here's what you're getting in this video. Not alien screams, not clickbait fog, a real step-by-step report on what James Webb saw, what other telescopes saw, what looks wrong at first, and what science says it most likely is. And then I'll tell you the one question that still doesn't have a clean answer yet. Let's start with the headline everyone keeps repeating. A new frame of 3I/Atlas. When people hear that, they imagine a sharp photo, like a spaceship selfie. Reality is less Hollywood. James Webb is a monster telescope, but it's not a magic camera that gives you a clean close-up of a tiny icy rock from millions of kilometers away. Most Webb images of a comet like this are about light and chemistry first. They're maps of brightness, spectra, and what molecules are glowing, not a crisp close-up where you can count cracks. So if you saw a so-called new frame and it looks odd, the first thing you ask is simple. What instrument was used? What was the exposure? What was the filter? And is this showing a picture, or is it showing data turned into a picture? Because those are two very different things. Now, quick grounding so we don't drift. 3I/Atlas is the third confirmed interstellar object humanity has caught passing through our solar system, after 1I/Oumuamua and 2I/Borisov. This one is active like a comet, meaning it's releasing gas and dust as it warms up near the sunday. It was first picked up by the Atlas survey, which is designed to spot fast movers and potential threats. NASA has been clear that it is not a threat to Earth. It did not come close. It's far. So why are people acting like it's a horror movie? Because it has a feature that messes with your brain, a sun-facing anti-tail. Most people learn one thing about comets. Tail points away from the sunday. That's the rule. So when you see a tail that looks like it points toward the sun, your brain says, hold on, that breaks physics. Here's the thing, it does not break physics. A so-called anti-tail can happen when you're seeing dust in a certain viewing angle. It's about geometry, perspective, and the fact that dust spreads along the comet's orbit like a long ribbon. Depending on where Earth is and where the comet is, that ribbon can look like it's pointing the wrong way. It's a known comet effect. Rare, but known. But now here's where it gets spicy, in a real science way. With 3I/Atlas, the anti-tail is not just a little faint streak. Observations reported that it looks sharp and narrow, and there are signs of structured jets that wobble with time. That's not aliens. That's a real clue about rotation, active regions, and how the surface vents behave when sunlight hits a spinning, uneven body. And that's where the new frame matters. Because one good observation at the right time can make the difference between guessing and measuring. So what are scientists trying to measure? They want the rotation period. If jets or brightness patterns repeat, the comet is basically telling you, I spin like this. All locks. They want the chemistry. Is it water-rich, like many comets we know, or is it weird? They want the dust behavior. Is it fine powder, chunky grains, or something in between? And they want to see if the activity changes fast, because changing fast can mean fresh ice is being exposed, or the surface is cracking, or the jets are turning on and off like a leaky valve. Now, let's talk about why James Webb is such a big deal for this. Webb is insanely good at infrared. Infrared is where many key molecules show themselves. Things like carbon dioxide, carbon monoxide, water vapor, and more. That matters because two comets can look similar in visible light, but be totally different once you check the chemistry. NASA's teams, working with Space Telescope Science Institute, aim Webb like a lab instrument. They can use tools like a spectrograph to spread the light out and see what's in it. So when you hear new frame, what you should hear is new chemical fingerprints, or new structure in the coma, the cloud around the nucleus. Now here comes the first mini cliffhanger. Because the public sees one image and scientists see a trap, moving target. A comet is moving fast and it's changing. So the telescope has to track it or you get blur. And in some modes, you're not even looking at a normal photo. you're looking at a slice of data. You can get artifacts. You can get shapes that look like lines, beams, or patterns that are not the object. They're the result of how the data was collected. So when someone says, look, it's a beam, I ask one question. Is that beam still there in another instrument, another time, another telescope? Because one data set can lie to you by accident. Two independent data sets agreeing is where the confidence starts. And this is why I'm going to keep this NASA style. If the claim is huge, the proof has to be boring. So let's eliminate the three biggest fake makers of contact. First, spacecraft quirks. James Webb has to deal with pointing, tracking, calibration, and detector behavior. Bright objects can cause effects on detectors. Moving targets can leave streaks if tracking is slightly off. If a processing pipeline tries to remove background stars, it can accidentally carve out weird shapes. None of this means the object did anything. It means the math did something. Second, processing artifacts. Anytime you see a leaked image vibe online, assume it's been processed by someone. Contrast stretched, colors assigned, noise reduced, details sharpened. And in that process, the human brain can be tricked. There's a simple reason. The brain hates randomness. It will invent meaning from noise. Third, nature making geometry. This is the one people underestimate. Nature loves symmetry. Crystals, hexagons on Saturn, spiral arms in galaxies, vortices in Jupiter's atmosphere. Even dust jets can look like clean lines. You don't need an engineer for geometry to show up. So the real question is not, is it geometric? The real question is it geometric in a way that can't be explained by dust physics, outgassing physics, and viewing angle? Now let's get back to what's actually unusual about 3i/Atlas without turning it into fantasy. One, the antitail itself. Not impossible, but rare. And it tells us we're seeing a special geometry. Two, structured jets that appear to wobble. That can reveal rotation and active vents. If a jet points in slightly different directions in a repeating pattern, it can be a rotating nozzle on a spinning body. You can estimate spin rate from that. Three, the chemistry hints being discussed. Reports point to carbon dioxide and other volatiles, plus detections of things like cyanide and nickel vapor in some observations. Nickel emission has been seen in comets before, but it still grabs attention because it's not the first thing most people think of when they hear dirty snowball. It's a reminder that comets can carry more than just water ice. Four, the timing and the coverage. During closest approach to the sun, some things are harder to observe because the object can be near the sun in the sky. That means gaps. And gaps are where rumors grow. People fill missing data with imagination. Now, here's a calm but serious point. We only have 3 confirmed interstellar visitors so far. That is nothing. That's like trying to understand the entire ocean after seeing 3 fish. So when something looks not normal, it might simply be normal for interstellar objects. And we're the ones who don't know the baseline yet. That's not scary. That's humbling. Now, let me explain what doesn't add up can mean without making fake claims. When people say something doesn't add up, they usually mean one of 3 things: the shape, the motion, or the light. Let's take shape first. A comet nucleus is tiny compared to the coma. Most images are dominated by the coma and dust. If you see a sharp, hard-edged shape in a processed image, it might not be the nucleus at all. It might be a saturated pixel region, or an artifact from stacking frames, or a background star not fully removed, or a tracker correction. So any hard geometry claim needs multiple confirmations. Next, motion. Comets can have non-gravitational acceleration. That means jets push them like tiny thrusters. It's not intelligent control, it's physics. Gas escapes, recoil happens, orbit nudges slightly. NASA Jet Propulsion Laboratory models this kind of thing all the time. But it's tricky because the push depends on where the vents are, how the object spins, and how the surface changes. So early orbit fits can look messy. People see changed course and think steering wheel. Usually it's just the model getting updated with better data. Then light. Light curves can look weird. Brightness can jump. color can shift. Polarization can be extreme. That doesn't mean it's artificial. It can mean dust grain size changed, or a new jet turned on, or the coma became richer in certain molecules that glow differently. Now, let's zoom in on the specific thing you're asking for. Are we telling listeners it was done by AI or not? Here's the clean answer. AI does not discover aliens. AI helps humans search through huge piles of data faster, and it can flag patterns humans might miss, or help remove noise, or enhance faint signals. But AI can also hallucinate patterns if you let it. It can overfit. It can find faces in clouds at scale. So if AI was used in processing or analysis, the honest way to say it is like this. AI is a tool, like a better shovel. It helps you dig faster. It doesn't decide what the treasure is. Scientists still have to verify with standard methods, independent teams, independent instruments, repeat observations, and physical models that explain what we're seeing. So yes, we can mention AI if it's part of the analysis pipeline, but we never treat AI as the final judge. NASA, ESA, and the science teams do not announce conclusions based on one AI run. They treat it as a clue generator. Now, let me give you a report-style rundown of what a new frame could realistically show and why it could look off. You might see a narrow streak that looks like a beam, explanation, tracking, and motion, or the way a spectrograph maps light into an image. You might see a clean dot with a colored halo, explanation, different filters or wavelengths showing gas versus dust. You might see a tail that appears to point toward the Sunday. Explanation, anti-tail geometry, dust ribbon alignment, and perspective from Earth. You might see repeating bright knots in the coma. Explanation, jets turning on and off as the nucleus spins. You might see a sudden increase in brightness. Explanation, outburst, fragmentation of surface layers, or a fresh patch of ice exposed. All of these are dramatic to look at. None require a spaceship. But, and here's our next mini cliffhanger, the reason this keeps people glued is because some of these effects are rare in interstellar objects, simply because we have almost none to compare. And that's where the real tension is. Not is it alien, but how different is it from what we've seen before? Oumuamua. So let's compare it to the last two. With one Oumuamua, one of the biggest debates was non-gravitational acceleration, with little or no visible coma. That led to a pile of hypotheses, from unusual outgassing to exotic shapes. Harvard astrophysicist Avi Loeb pushed the artificial idea publicly, but many other scientists argued for natural explanations, including unusual outgassing mechanisms. With 2I/Borisov, it behaved much more like a normal comet, just from another star system. Now, 3I/Atlas looks comet-like, but with some rare features and some unusual measurements. That places it in the middle zone where the public gets restless. Now, we bring in some names, because this is how real science looks. NASA Jet Propulsion Laboratory does orbit determination and models non-gravitational forces. NASA Goddard Space Flight Center supports missions and science operations. Space Telescope Science Institute runs James Webb science operations with NASA and ESA. European Southern Observatory runs big ground telescopes that can watch the coma and tail structure. Keck Observatory in Hawaii can do detailed spectroscopy from the ground. The Harvard-Smithsonian Center for Astrophysics is deeply involved in interstellar object studies and houses a lot of expertise. And the Minor Planet Center under the International Astronomical Union is where the orbit observations get collected and checked. This is not one person staring at a blurry picture at midnight. It's a worldwide network. Now let's get to the part people actually feel in their chest. What if it changes? Is eyes. Because your title says something doesn't add up. So here's the most honest place to put that tension. The gap between observation windows. When the comet goes into a region where it's hard to observe, like near the sun in the sky, we lose eyes on it. And if it's active, it can change. Jets can shift, tail can reshape, brightness can change. When it comes back into a cleaner viewing window, the first new data can look shockingly different. That is normal for active comets. But when you're talking about an interstellar object, normal feels like unknown. So the reporting angle that hooks people without lying is this. We've got a real object doing rare comet things in a geometry that makes it look even stranger. And every new data set makes the models tighten up. Now, I want to give you a clean what we know right now list, but I'm going to do it in plain talk. We know it is on a hyperbolic path, meaning it came from outside the solar system and it's leaving. We know it is active like a comet. It's producing gas and dust. We know it has been observed by multiple telescopes, including NASA assets. We know it posed no danger to Earth. We know that the antitail and jets are interesting and likely connected to dust, geometry, and rotation. We know that James Webb observations are valuable because they can detect and measure molecules in infrared that ground telescopes can struggle with. Now, here's where the suspense lives without breaking reality. What we do not know with high confidence yet is the exact structure of the nucleus, because the coma hides it. We do not know the exact layout of its vents and how they evolve. We do not know whether its chemistry is typical for a comet from another star or truly odd, because again, sample size is tiny. We do not know if the activity will fade smoothly or if it will have more outbursts. And we do not know the detailed dust grain properties without deeper modeling. Now let's build toward our first major oh wow moment, still in report style. A sun-facing antitail looks like a violation. But when scientists analyze antitails, they don't ask, why is it defying the Sunday? They ask, what is the dust doing? Dust grains have sizes. Big grains behave differently than small grains. Radiation pressure pushes small grains more strongly. Big grains stay closer to the orbit path. So if 3I/Atlas is shedding certain dust sizes, the shape can become sharp and column-like. And if the nucleus is rotating, a jet can sweep like a lighthouse. So if you see a repeating swing in jet direction every several hours, that can match a rotation period. Here's why this is a big deal. Rotation tells you about internal structure. Spin too fast and it breaks up. Spin plus heating and it cracks. If it stays stable, it might be more solid than some comets. And that stability matters because as it passed perihelion around late October 2025, it took the strongest heating it would get. So a stable pattern after that heating is in itself an interesting data point. Now we drop the next doesn't add up moment, but correctly. Sometimes the orbit bend and the jet direction can look visually too neat, like symmetry. But a neat looking bend can happen because we are measuring the orbit with uncertainty, then updating it as more observations come in. The symmetry can be accidental, or it can be an illusion from plotting. This is why NASA and the Minor Planet Center keep updating orbit solutions. It's not a cover-up, it's how tracking works. Now, let's talk about January 2026 vibes, because you mentioned alignment, and people love that word. Planetary alignments are usually not mystical. They are line-of-sight events from our viewpoint. The solar system is a 3D place. So alignment is often just a few bodies look like they line up from where we're standing. Still, geometry matters in science because it affects what we can observe and how. If a comet is near the sun in the sky, it's harder to observe. If it passes near a planet's region of gravitational influence, models get interesting, not because of magic, but because gravity changes the path. With 3I/Atlas, there's interest in how it passes through the outer solar system and what we can still observe as it heads toward Jupiter's neighborhood later on. Not because Jupiter will catch it like a net, but because Jupiter is massive and the geometry can produce a noticeable change in trajectory if the pass is close enough. So when people say it's moving into position, the sober translation is we're entering a window where gravity and viewing angles make the next data valuable. Now, I'm going to do something important. I'm going to separate what is real reporting from what is speculation. Real reporting. NASA has publicly discussed 3I/Atlas and published pages about it, including observation updates and images. Reuters has reported on NASA briefings about 3I/Atlas and included expert voices saying it behaves naturally. Space reporters have covered studies describing wobbling jets and anti-tail behavior. That's the safe ground. speculation. Leaked images with beam claims, secret silence orders, encoded RNA in emissions, satellite failures linked to the comet. Those claims require hard proof. And if we don't have that proof from credible sources, we do not present them as fact. What we can do, if you want the darker vibe, is report that rumors exist, then explain why rumors grow in data gaps and why real verification takes time. That keeps engagement without lying. Now let's tighten this into a clean, gripping report arc. The reason people are stuck on this new frame is because it arrived at the worst possible time for our brains. After a run of headlines about interstellar visitors, after the memory of Oumuamua debates, and right when the internet is primed to see meaning in anything unusual. So you show one odd-looking comet frame, and the world splits into two camps. Camp 1 says, it's a rock. Camp 2 says, it's a message. Our job is to stay calm and do the checklists. Checklist 1, does the feature repeat? Checklist 2, does it show up in other telescopes? Checklist 3, can physics explain it without stretching? Checklist 4, if it can, stop. That's the answer until new data breaks it. Now here's the next hook moment. The antitail wobble suggests a measurable rotation. And if the rotation is around 15 hours range, that tells us it's not a tumbling chaos ball like some people love to imagine. It's spinning in a way we can track. That already pushes us toward natural comet with structured activity. And there's more. If Webb sees strong carbon dioxide signatures, that tells us something about where it formed. Carbon dioxide can be trapped in ices that formed in cold environments. Interstellar objects may carry chemistry that our local comets don't show as strongly, or they may show it differently. Either way, it's a lab sample from another star system flying past for free. Now, another mini climax. The moment scientists say nickel, because nickel vapor emission sounds like metal being cooked off. In reality, comets can show atomic nickel in Comet. It's been reported in other comets too. But it still matters because it points to the kinds of elements and compounds present, and it becomes a clue about dust and gas chemistry. So if your new frame lines up with spectroscopy that shows certain molecules, the picture stops being a weird photo and becomes a map of real chemistry. Now we bring it back to the title. Something in it doesn't add up. So what is the most honest doesn't add up that keeps people watching? It's this. Even with known comet physics, interstellar comets are a new category with almost no baseline. That means our models are going to be stressed. And the feature that will keep being debated is the anti-tail structure and jet timing. Not because it's impossible, but because it's rare enough that every team will want to test their assumptions. One team might model dust grains one way and get one result. Another team might model them differently and get a different result. So the public sees disagreement and says, cover up. In reality, disagreement is the engine of science. Now I'll give you a strong mid-video reveal that feels like a climax without saying the word. The new frame does not need to show a spaceship to be unsettling. It's unsettling for a quieter reason. It shows how easily our confidence breaks when something comes from outside our system. Our categories are built on local comets, local asteroids, local behavior. An interstellar comet is like meeting a stranger from a place you've never been, who speaks your language just enough to confuse you. You think you understand them. Then they say one sentence that makes you realize you don't. That's 3I/Atlas. It looks like a comet. Then it shows an anti-tail and structured jets. And suddenly every comment section is on fire. Now we add one more layer that hooks people, timing. NASA has noted that this object's closest approach to Earth was far away. It also passed closest to the Sun around late October 2025, around the orbit region of Mars. And it continues outward with future observing opportunities as it moves toward the outer solar system. This matters because new frames do not arrive evenly. They come in bursts when telescopes can schedule observations and when the geometry allows. So the internet gets a drip feed. Drip feeds create obsession, and obsession creates fear. Now, Before we close, I want the report to land on one powerful question that feels scary but stays honest. Here it is. What if 3I/Atlas is not weird at all? What if this is simply what interstellar comets look like, and we've just been blind because we haven't had enough time, enough surveys, and enough luck to catch them? That idea should hit you harder than aliens, because it means this. The solar system is not a quiet neighborhood. It's a highway, and we're just now building the cameras to see traffic. Now, let's lock in the last major attention spike before the conclusion. People keep asking, why would it hide behind the Sunday? Here's the reality. It doesn't hide. It moves along its orbit. Sometimes that puts it near the sun from our line of sight, and observing becomes difficult or impossible. That's not stealth. That's geometry. But from the human side, it feels like the worst kind of timing. The moment it's most active, it's hardest to watch. So the mind fills the gap, and that is exactly why NASA, ESA, and observatories keep pushing for multiple independent data sets from multiple angles across time. Because the only cure for imagination is more measurements. Now, I'm going to wrap this up in a way that keeps the tension without pretending we know what we don't know. If you're seeing a new frame of 3I/Atlas and something looks off, don't jump. Ask what kind of data it is. Ask if it's been processed. Ask if it's repeated. Ask if other observatories see the same feature. Then check what the best scientific explanation is. Right now, the strongest explanation is still the boring one. A natural interstellar comet with rare geometry creating an anti-tail, and structured jets revealing rotation and changing activity, made more dramatic by how our viewing angle lines up. And that is already incredible, because it means we are watching raw material from another star system reacting to our sun in real time. No science fiction needed. Now, subscribe if you want updates when the next verified data drop lands, because the next time James Webb or a major ground telescope takes a clean look, we're going to know a lot more than we know today.